Hello, everyone. So we'll be waiting for a couple of minutes for everyone to join. We'll be starting 5 minutes after the hour.
Hello, do you hear me?
Hello, yes. Hello, Laurent.
I didn't hear you, Alex. I saw you.
Oh, you can.
That's good. Okay.
Yeah, just said hi, yes, that we can hear you. And we'll be starting in a minute. All right. So we are 5 minutes after the hour. And we can start. So, hello, everyone. This is an official interim meeting, an official meeting of the IETF. So, as all such meetings, all the rules and practices of the IETF apply, and they're all noted here in the note 12. So, by participating, you agree to follow all the processes and policies, and I encourage you to, of course, read all the BCPs that are listed here in detail. So for today's meeting, we're having it's going to be a shorter meeting, I think, because we have one item, which is a presentation of the universal options document by the authors that are listed here. And yeah, so basically that's the point. So do you have any questions or any other additional items that you would like to discuss today? No, I don't hear anyone. So with this, I think that we can continue. Like I can give you the hand, Laurent. I think that you are going to present. I'm not sure who is going to present. Are you presenting?
Yes, I am. I just upload the slide. I don't know if you got them or
You have a new version now? Because
no.
there
I
was not.
10 minutes ago or 15 minutes ago.
Yeah,
Did
I
you?
saw it. Yeah, I
Okay.
saw it. I saw it on the data tracker, yeah.
Yeah.
So
Okay.
yes, and let me give you the hand, and this way you can switch the slide on your own.
Thank you. Okay, so I will talk about universal options, which is a draft in version 01. So we had a first version, I think it was before Christmas, and we had some comments on the list about some details, and especially the group asked for more numbers and to make the comparison. So it's what we have did in this document. So and we have a newcomer since Quentin joined the group for this time. So the idea, so I tried to summarize it here in a small slide, is that now we are, Chic is leaving the LP1 world and is going to be anywhere or at some places. And we don't have such predictable traffic we had with IoTs, because IoTs, you have a firmware and then you don't change, so you know all times the traffic. Here it's more, for example, to study a case where you have a node A that talk with a node B, and we have in the middle two Chic instances that are doing the compression of the traffic. So we need to have rules that describes the traffic, and of course this traffic can evolve. So we can use rule management to configure the other end with new rules that will optimize the compression. So that's a new model we are investigating with the Chic. So what does it mean? It means that we may have trouble with some things that are not described at the beginning or when we install the S1 and S2, and may appear after during the life of the system. For example, new options that can appear. So the question is how we can continue to have the compression working if a new option, an unknown option, arrives on the network, and we have to compress it. So normally, option has, if we look at CoAP, option have a specific syntax, very well known. So if a new option arrives, the parser will be able to parse this option. But the problem is to how to identify this option in a Chic rule. And here we had two approaches that where we have a lot of discussion. One is what we call the syntactic way. It means that we are very, very close to the wire representation of an option. And we have a semantic way, which means that we have something more abstract, and we create an abstract header or an abstract field, and we do compression on this abstraction rather than what is really represented on the wire, and the work to go from the physical or the wire format to the abstract format is done by the parser and vice versa by the unparse on the other end. So what happens, what is the problem that has been raised by Quentin is if, for example, you have a new option that arrives, so as I say, S1 will be able to do the parsing, but then he discovers a new value for an option, and he has to send a management message to say, hey, there is this new option. But right now, as it has been defined in SCHC, we need a field ID that is manually assigned to this. And if it's a new option, we don't have this manually. When I say manually, it's all the stuff with seeds, etc. That is missing. And so we can do everything except represent in abstract manner the option. So the goal of this document is to describe different ways to do this. So as I say, we have these two ways, syntactic versus semantic. So syntactic, as I say, we are close to the wire. So for example, with CoAP, it means that we are going to proceed three fields, the delta t, the length, and the value. And the benefit is that if we go at this level, so we don't care of the value of the delta t, it can be any delta t available. And so it means that we don't care really of the nature of the option. We don't have to represent it in another way. And we have this, yes, Alex?
Yeah, thank you. Just one question. Have you discussed the use of the term syntactic? Because I mean, I understand like syntactic and semantic. This speaks to me, but here it's basically you're taking the values like in as they appear in the co-op options, and then you put them directly on the wire. So
if you have another name, you can propose it.
is it something like transparent? No, yeah, I mean it's. Yeah, I don't know. It's just in my mind. I mean, I've read the document, but like here when you were talking, I was not sure what it is. And now, I mean, I saw your description. And okay, it was this thing. So maybe think of a new term. I don't know.
Yeah,
Maybe it works. It works for other people, right? I don't know. It's just for me.
we are open. If you have other names, it's okay. But so right now we call it syntactic for the rest of this presentation, and we have the semantic way. As I say, we go on an abstract notation, and here the problem is that we have a lack of field ID for new option, because if we look at the core conf representation, or is the young, but we focus on the core conf, is that we need a seed for this new option, and if it's a newcomer, never seen before, then we don't have it. And in some case, you can create and what was in our mind when we design it, is to say, because we were in the LP1 vision, is that in that case, you create a new young data model, you extend the existing one, and you create your seed ID for this. But for new options that are never been seen before, then we have a problem. So it's so we have to solve it in that way. So in the document, I don't go in the description of all the things that you have in the document in a more formal way. In the annex, we put some measurement, and we use a stupid co-op message that is just here to test things. And we define a rule that when it's in yellow, for example, it's things that are elided, not sent, and what is in blue are the things we are sending. So we are sending half of the message ID, the URI path, the real query. We don't send an accept or no response, and we introduce a new parameter that exists in INR registry. I don't know what is used for, but it has this value, and suppose that this SPC 82 is unknown, and is really unknown from the SCHC point of view, because we have no field ID for this one. So we compare different approach. So regarding the semantic, we have a pure 9363 approach, and the other one is we augment the 9363 with this concept of universal options that are used to I will explain after, to carry the same identifier as in the protocol we are compressing. So for this, we look at three ways to represent the seeds. The first one is independent augmentation. It means that we create a specific data model just for this new option, like SCP-82, which means that it's not working if it has never been seen before, but suppose that we know it. So we have this data model that will take it. And then, so it's two independent things. Then the second evolution is when we say, okay, we incorporate it in a new version of the young data model for SCHC, so what we call 9363 revision. And the last one is to have a clever allocation of seeds in the range, in the pool we have, to optimize the core conf representation. So this is one, it's all these four things. And then we have the syntactic approach, where we look at the packet as TLV, or delta T, L, and V. Okay, so for pure 9363, so we look at three things in the document. Here I represent only two. One was the size of the rule in core conf. The second one is the size of a query, like a fetch, to get access to one specific element in the data model. And the third one is the size of the compression residue of the SCHC packet by itself. So here we have an example of pure 9363. So what we see that this representation is 355 bytes. And you see 300 in blue is the last 6 that correspond to the CSP82. So it means that we need to define this field ID in a new data model. And so it's here, and is instead of, you see so to be readable, because this is canonical as a representation of CBOR. So what we did is I put in at the beginning here, you have the deltas. And so when you see that it's a delta 6, it means that it's field ID. When you see delta 7, you see it's a field length, etc., etc. So if we look at the key 6, we know that it's a field ID, and we have the value 5055, that is the IPv6 version. And so we have sorry, it's not IPv6, it's CoAP, so it's CoAP version. And we have the last one in blue. So you see that the field ID space is not the same one as 9363. It's a new model that has been augmented, and here we are in 10,000. So here it shows how we can represent it, and it doesn't work if you don't have a data model to represent this thing. But it gives the reference on the size of what we are going to send. So the goal is to change that with universal option. And universal option is augmenting the data model. And instead of having just when you have an entry, a list of entries, you have the field ID, then you have the field length, then you have the field position, etc., as represented here. And in blue, it means that we augment the data model with a new list of entries a new kind of entries that are composed of two more things. One is a space ID. So the space ID is something that say we are in the co-op environment, and another space ID that after the space ID, sorry, we put, for example, 11. So as you see in the first line in the blue, and 11 is the option for the value for URI path. And if you look carefully, you see we have 11, 11. So 2 URI path, then 2 URI queries, and an accept, and then you see the no response and this SPC 82 option 2055. So here you see that we keep the value we have in the co-op header, and before we add the space ID that say we are working in co-op. So it means that here what we have to do is to create a new structure, because we cannot just do it very simply, because this is they have keys, and when we have the regular option, for example 6, so what we have defined in 9363, so the key was the field ID, the field position, and the direction indicator. And here we when we do the space option, the universal option, the field ID is not enough. We cannot say just is co-op, but we have to take 4 values for this, which are the rule ID value, the rule ID length, the space ID, and the option ID that is written here, option values, but it's the option ID. So it means that here, if you look at the query, the fetch query, instead of 14 bytes, as we had before, here we add 1 byte because we have to put the option value that is taking more space. So here in this example, we use universal option, and we say that it's an augmentation of the model. So regarding the seeds, we consider that 9363 is in the 500 range, and that the extension is in the 5,000 range, and the extension that we put here in the 7,000 range. So 2 seeds that are allocated at different space and so the impact is that we have deltas when we code them that are very huge. So here, for example, we have a delta that, for example, 1916 that is coded in 3 bytes. So you see that since we have to repeat all the structure, we have 3 bytes for each value of this entry, each key of this entry that has to be added. So it means that here we had a model before that were of 357 bytes, and we go now to 481. So we add more than 100 bytes to represent this. But this way we have something that is universal, because we just need to define a space ID, and then any option in this space ID can be carried. So can we optimize this? So one way is to say, okay, we do a revision of 9363, and we integrate directly in the data model this extension. So this augmentation. So with a revision, it means that we will be in, when we allocate seeds, we will be in the same range, and so the delta will be smaller. So here, when we do that, we just use the regular allocation based on the alphabetical order, and we have this representation. So the problem of this representation, so the number of the keys are smaller, so that's good, but they are larger sometimes from 23. For example, feed position is 25. Matching operator value is 27. Target value is 30. So it means that we need 2 bytes to code them. So maybe that's a small problem, because we reduce the size of the data model from 481 bytes to 400. So it's a good benefit. But we can be a little bit more clever, and we allocate the seed manually. And by allocating manually, it means that we are, when we go into the hierarchy, each time we try to add a distance of 23 between each level of hierarchy, and then we fill the gaps between this level, which means that we can have positive and negative values. So here so in the draft you have an example of this allocation, and this way we can have all the values that are coded, all the delta, all the keys that are coded in 1 byte. And so this way we have a result of 376 bytes, which is quite good. We reduced by almost 100 bytes all representation of the single row. So here there is no change in any RFC, it's just a clever allocation of the seeds. So here it's for the first approach, so the semantic approach. For the syntactic approach, there is no change at all. The only thing you need to do is to allocate some field ID for delta t, for length, and for value. And when you have this, you are able to do the representation. So of course, this has an impact on the parser, because the parser has to stay at the very low level. But after that, all the compression environment is absolutely not modified. It's just the way we parse and the way we represent the rules. So it's what we have here, and we make some comparison. So here, this table summarizes all the value. As I say, we have the core conf representation for semantic. So it's a value I gave. So for syntactic, we have a very huge representation, because for each entry, for each option, we need 3 entries. So even if we optimize things, we have something that in this example is repeated 7 times, and so it increases the size of the data model. For the query, so we saw that moving from a pure 9623 to a universal option, it will take 1 byte more when we go to an option. And for syntactic, there is no change. We'll go directly to the value. And regarding the compression, so the compression for semantic is always 49. It has no impact on the compression by itself. And for syntactic is a little bit higher, because if we want to be generic, we have to send the size of the value twice. One for sending the field length, and the other times where we are sending the value can be represented as a var, and we have to put the length before. And that leads to a little increase of the compression residue. Okay, so to finish, and I give my conclusion. So this is my conclusion. Maybe we don't have discussion with Otfer, so maybe they may have another view, but so is that syntactic approach can be very easily integrated into the SCHC architecture. There is absolutely no change. We just need to create a new data model to define these 3 fields. So that makes that SCHC is very flexible. And of course, we have to update the parser just to do the parsing in a different way. And it can be, so the advantage is that it's very, very flexible. So for example, if we have options that we don't know the value and we want to ignore it. It's a way to do it. It's more difficult in the semantic approach. But the main problem is the size of the rule when it's represented by core conf that make it larger. So for the semantic approach, we have better performances, but we have also to modify the parser to do it. And we need to change 9363. And I think the better approach is to make a revision of the existing data model for several reasons. The first one is that we have better representation for core conf. And the second one is that maybe there is some missing things that has to be added. For example, we didn't specify in the data model that the entries has to remain in the user order and doesn't have to be managed and rearranged by Yang. And that can be a very serious problem. For example, if for the compression is not a problem if you manage the entries and at different position, but the residue, if we don't have, we agree on the order, the entry order in the rule, then the residue will not be understood by the receiver. So it means that we have to take very be careful on the way we store the rule and the way and be sure that they are in the same order on both ends. So it means that there is an option in Yang that say that it's a user order, and we have not specified it in the data model. So for me, just for this, is good to have a revision, and it will be a good opportunity for innovator options. And the other thing is that for the group, it's good not to use the alphabetical order for the seeds, but we have to do a manually allocated seed file. So that's where we are right now. There is other discussion in the group about a way to flatten the model. It means that in that case, we don't integrate the entries directly in a rule, but we have a list for rules and a list for entries. And then in the rule, we are pointing out on these entries. So this way, for example, if you have IPv6 version, you don't have to repeat it as many times as we have rules, but you can have a kind of pointer to this entry. But this may have some more impact on the RFC. And here it's not clear for me, at least, how to do that. And I think that this discussion is really related on the rule management and see what we are going to do in management. For example, if we just say copy this rule, rule 3.5 to 5.5 or 3/5 to 5/5 and change this target value to this.
Laurent? Sorry, I just wanted to say that I think that the discussion on the flattened model needs a separate time and space with something to show. Like it's really, at least for me, it was difficult to understand exactly where to go. So maybe not like I think it's a very interesting topic, and it merits to have like a separate discussion, right? With illustration.
But that was
because,
my topic. So,
yeah. I mean, because it's really a very elegant thing to consider, and with a simple example, I think it clarifies a lot of the things.
Okay, so just to finish, I think we can continue to ask for a seed file or seed range for the data model, and that we will adapt then dynamically to evolution of the data model.
Oh, okay. Well, thank you very much. Thank you very much for the presentation. So how do you what do you think? I mean, from like from the presentation part, the page where you showed like the comparison of the payloads that you have, like the comparison of the different solutions. Can you go just like 1 or 2 slides back? Yes, here, for example. So I mean, like the first reaction, like very basic reaction is, I think that typically you will have a much more traffic, like much more, normally you have much more data packets compared to management packets. You know, if you create a rule, then probably you'll have several, many data packets using that rule.
Yeah.
So probably having a solution that is that provides better compression would be better compression of the SCHC packet would be preferred, even if it results in bigger core conf or query messages. Is it do you am I so what do you think about this? Does it sound reasonable, or I'm or you or not that much? I don't know.
To whom are you talking? To me or to the
Yes,
group?
well, to you and also to the people in the group.
So I think the big problem is when you are provisioning. So if you, it's where you are sending all the rule. After that, if you just send delta, it's different. But it means that you may double your size.
Yeah, but I mean, the point is that you provision once, right? Then your device will be sending, like, I don't know, days and days and days of data probably. So I see Quentin is also wants to say something.
I was about to say exactly the same, that provisioning growth is not happening that often. So it might not be the biggest problem that we have. And then the question is about the size of the packets. And in this case, this has to be confirmed in actual like data sets of traffic captures. Because I mean, in this case, we made very generic rules where the option value would be of variable size. And in many cases, I mean, the one that we see in our work, the value itself is, I mean, the value changes, but the size of the value is something that is very static. So, I mean, the difference between the size of the residue between the different approaches is about the same in the end. This would be my conclusion. And also, I believe there are also different things that I mean, especially Laurent mentioned all of the question that we need to change this or that in the data model and etc. This is also something to consider, I think.
Yes, so you mean that here, if I understood correctly, that here for the SCHC packet, so it's like 52 bytes for the syntactic way of working, that it could be optimized, it could go down to 49 bytes. Is this what you meant?
It's, I mean, for this very specific example where we don't know the size of the value, if you don't know the size, then you'll have to pay for it. You'll have to pay it, and that's the figure is correct. What I'm saying is that in many cases, the option value is of fixed size. Consider for example the case where you have lightweight M2M on the top. Then the value is not known, but the size is static. So it means that you don't have to encode the variable size in the SCHC residue.
Okay.
Which means that in some cases the difference between the syntactic and the other approaches will be less.
Yes, Laurent, go ahead.
Yeah, so maybe this is true for co-op, but if you look at, for example, TCP, you may have, for example, an option that gives you how many bytes you can send, and this will vary. So it means that you cannot say that you can forecast always the content and option. Maybe this is something that is quite particular to co-op or to some traffic on co-op. Maybe there is over traffic where you may have options that ask for a specific time or things like this, where you cannot forecast what is in the query. So that's one point. The other point I forgot to mention is that in syntactic, we still have the problem of the representation of the length or in a rule, which means that it's ever coded in 4 bits, 8 bits, or 16 bits. And when we want to be very generic, we have to, of what I say, I don't see any other solution. It means that we need to repeat to have several rules, one for a length of 4 bits, one for a length of 8 bits, etc. And if you have different rules, if it appears several times in a rule, then you have to define, for example, if it happens to 2 entries, you need 4 rules.
Yes, Quentin, I think you wanted to add something.
Yeah, I mean, just to confirm that there are cases where the option value length is going to be bigger than, I mean, the discussion, to be precise, is about the different cases where you need extensions to the deltas and also extension to the length field in the options. So in some cases, an option can be more than 3 fields. It could be up to 5 if you have a delta extended and also an option length extended, which is what Laurent explained about having 4 plus 8. Well, the question remains the same. I mean, how often are you going to see for a single device that many configurations of option value lengths? And yeah, I agree in a very generic and a very kind of like broad view. The semantic approach where you just expose the field ID and the option value seems like a solution that simplifies things at the cost of a more complicated parser, unparser, and also a more complicated data model. But yeah, I mean, both options are, I think, interesting.
Yeah, they are not exclusive. So
exactly.
So it's not a problem in that sense. I just want to mention, as I said before, is that we're not doing this only for co-op. And so we can, when option, for example, are used in TCP, it means that they carry some information that may vary. And if we want to compress TCP with this, so we have to make that we don't know the value of an option and we have to send it, not only elide it.
Yes, Quentin?
Yes, just to develop a bit on what Laurent said, there's the question of solving the issue with co-op. And then there's the question of the same problem that could appear with different protocols. So the idea that the universal option could be one way to not only solve the issue with co-op, but maybe address options outside of co-op. And I believe this would require well, some interesting studies on different protocols and extra.
Mm.
Yeah. for sure.
Actually, that was a question I was about to ask you. Do you think it would be useful to have like a list of potential protocols we aim at initially, at least? So obviously there is CoAP and there is TCP. Do you see other protocols that should be included? Yes.
In the draft, we mentioned MQTT.
Okay. Okay. Yeah. So like if there's yeah, I think that this is the work we need to continue working on and probably at some point decide which way to go, either syntactic or the semantic way. But also like probably we'll need to say a little bit like, okay, if there is like a trade-off to be made, way like what would be the criteria? Like one of the criteria we said is probably we want to have like the smallest possible SCHC packet, even if the management messages are a little bit bigger, right? So just to see if this is something that that we need to consider. Quentin? Yes.
Yeah, I was about to say that both options can be. I mean, they are not antagonists. You can do both, and I believe that yes, there's the question of how small the residue can be. That's for sure. This is an important point. To be able to kind of like get a final conclusion on that, we'd have to actually study actual data sets of CoAP traces. So I believe this would be interesting, especially because we're making this assumption that what we're really pursuing is the smallest residue, which makes sense for the LP1 case. It might not be the single objective for the more generic use case of SCHC over the internet, for example. I believe that complexity might be also an important factor, especially when you're considering having an unparser and a parser for each compression that appears on two equipments in the network. Especially in the case where you have very high amounts of traffic to compress and decompress. So yeah, I believe that the question is how do we solve the case for CoAP, and then the second question is how do we solve the problem of options in protocols in the more like broader setup. But the kind of like the objectives are not necessarily the same for both cases.
Yes, exactly. Exactly. So just I see Laurent also coming. I wanted to ask Pascal something. Pascal, so I mean, because the way I feel it is so Laurent, I wanted to ask a question because it seems I think it's an important work and we have a use case here. So would you like I'm not sure. I think it goes into our charter. So are you going to be aiming for document adoption? Working on document adoption?
Yes.
So,
yeah, just one point. Yes, and I think that Quentin should write also a specification for syntactic in another draft.
I'm
okay. Yes.
a little bit concerned that we have not really stated which objectives, which use case, etc., we are willing to serve with this new work. And as I think I heard from Quentin, depending on which objective, which use case you want to serve, it might be that one way is better than the other or something. For instance, are we aiming at a very specific solution for one use case where the traffic would be the packets will always be in the same order of things, and it would last for years, in which case it's almost like designing one spec for one application, one use case? Are we aiming at one solution that's the best, fits it all type of approach?
Uh,
I'm just confused that it's
So-
hard to figure out what we want to do if we don't have a very precise goal to meet.
Yes, Laurent, just a second. I see what you mean, Pascal, and yeah, you're right here. So I think so. This is definitely a work I would love to see us working on, and maybe what you're pointing out is the slightest question. That is, okay, how are we going to decide later on? Are we going to pursue syntactic or semantic, or maybe something else, right? Between the two, I don't know. So what would be the criteria? What kind of traffic and so forth and so forth. If so, the question is: would you like to try to solve this question now, before asking for working group adoption, or can we say, hey, well, we would like we will like the group will be working on specifying exactly the question that we're going to be solving, and that will happen in the next months, I don't know, and the final document is going to be really strict on that. So yeah, I mean the way I was talking, like I got a little bit divided in my thoughts, right? So look, then maybe I will ask the authors: do you feel like, how do you feel? Do you think that it would be possible to try to specifically state, okay, well, these are like the objectives that we see for TCP, for CoAP, and for MQTT, let's say. These are the main objectives that we will pursue. And of course, we can discuss that in the group, in the working group. Do you feel that that's something too doable now, or is it too early? Probably, I don't know.
So I don't know if I answer. I think it's related to Anna's work on flow compression. So it's something so we need the management. We need to do something that is changing. So for me, I will ask for group adoption right now, and then we can discuss. Because if we delay too much, then everything is blocked. Because if we don't have this, then we say, do we allocate some seeds because I'm not sure that the data model will be the one, etc., etc., and we postpone everything and nothing is going forward.
So is the flow the flow control? I don't remember. Is it a working group item? Because if it's not, I think it's important that we also include it, like that. Like we cannot have a dependency on it on a working group item, right? I mean, we could, but we could. It's not like the law, but you know. Yeah, so I mean, I see that there is something that is pretty simple and pretty clear in terms of objective for the document that could move forward, but probably the and maybe that's what Pascal also was suggesting, is that this universal option can either be very neat and done quickly with a specific scope, or we can get lost in trying to solve something very, very large, and we don't know exactly what it is, and we just get drowned in it, right? So maybe that will be the difficulty to I actually think that before adopting it, we need to say, okay, well, we are going to try to solve this thing, right? And if we are capable of saying, okay, it's going to be this, this, and this, but like that's it, then good. But I don't think we should leave it open so much. So Marco is saying that it also affect the 8824 update. So that means she needs to be like streamlined. Yes, I don't know if Laurent or Quentin is next.
I don't
Yes,
understand the second, and I was after Quentin, so, and I'm first. I don't remember what I wanted to. The fact is that in implementation, it was quite easy in OpenShift to do it. So there is just change in the parser, and then the rest was equivalent. The only thing that was, you have to write code to handle the serialization of universal option, but that's really very simple change in the code. And syntactic was done without any change. It's just the parser that has to be adapted to generate new fields. So for me, it's not a huge change in what we are doing, but it improved a lot. And I don't understand about the case study or what Pascal asked for, because at the beginning of the document we say that we have option, we don't know the meaning, but we know we know the format, and we are able to compress it. So that's the scope of this document.
Okay, thanks. But then it doesn't need any reference to any other document, right? I mean, the 8824 is going to reference this document, but this document will not reference any other document, right?
This document will just reference 9363, and yes, there is some details. For example, if we have score, we split an option in different subfields. Then here we need field ID for this, so they will appear in the 8824 update. But it's a non-option because we are describing how to split it. So
yeah, but what I meant, it can reference, of course, all existing RFCs and the 8824 because it's direct update, because it's directly, but it doesn't require any other document.
No, it's something that just change the space identification and say don't use a separate space, but use the protocol space you are compressing.
Okay, thanks, Laurent. Quentin, very short.
Yes, I was about to say that actually the problem was raised because of the 8824 update. I mean, the question on how do we deal with those new options. And there are two different avenues. One, which is how do we solve the problem that has been identified. And there's a kind of like a solution to a bigger problem that is proposed in this document, which has a different scope. And I believe this was the idea of Pascal. Since the scope is bigger, what exactly are we going to address with this new solution, and what are the objectives that would qualify a good solution to this new problem? So just to say that we have published a data set, a co-op data set that is based on Leshan for the client and the server. And that could be used for doing kind of like a quantified qualitative and quantified comparison between the different options, if that may help the working group make a decision. And probably I would say that it would be good also to have feedback on the document from the working group and the mailing list.
Okay, so sounds good to me. What I suggest is, because it's the top of the hour, like I was thinking, okay, this is going to be like a short meeting, and here we are. but it's very interesting and very important work. So thank you all. So what I can propose you is, let's take the time from now until the next interim for the people that have not read the document, or we can start working group adoption discussion now, and people will read the document and will say, like, if it's okay for them, or if it needs to, like, if we need to scope it a little bit more. So for me, the document needs to be adopted, right? I just want to see if there is consensus, in sense that it is sufficiently specific, right? That we're not going to boil the ocean with it. I think that we are not, and we have all the things necessary, just to make sure. So I propose that we start a working group call for adoption, and we take it, like, if there are requests during this time to say, hey, well, we need to scope it a little bit better, well, we'll just continue the call for adoption. It will take like 2 weeks more or something like that. Is it okay with you, Pascal? So start the adoption call and
Tell me, Alex.
Sorry?
Yes, I'm good.
Okay. So we'll thank you. Then we'll start the call on the mailing list. And for everyone, like, take the time to read the document to see if you have any wishes or last any comments before it gets adopted. Of course, all of the work will be done after, but, like, just if you have any concerns that maybe we'll be doing a little bit too much. I don't know. So with this, thank you all for being here, and see you in 2 weeks' time. Bye. And very special thanks to Marco for taking the minutes. Thank you, Marco. I don't know what we could do with it. We will do without you if you are not here.
Thank you so much. Bye-bye to you 2 weeks and about the mailing list.
Yes.
Bye.
Bye.